Right. Okay. So quickly we will go to the a snippet of the improvements or the features that we are going to talk about. So there's been a lot of improvements in the partitioning area, indexing, and sometimes you might even be surprised to see that the database size when you dumped it to Postgres 12 is smaller when compared to Postgres 11 or previous versions, right? Okay. You would see some of the reasons for that, and you'll see how some of the improvements have been happening on the standby side, or some changes which are quite different from the previous versions, wherein you might have to change your HA scripts if you have done some things manually, and some of the optimizer improvements that really improved performance. At the same time, we'll also see some of the monitoring options that are, features that are enabled through some parameters, as well as views, and some of the security improvements and authentication improvements, server configuration changes, and general performance and partitioning related general performance improvements, and some of the new functionality, client library, and some of the deprecated features. And also we'll see some of those tools that have got really minor changes. But this should be interesting to see based on some of the benchmarks that we have done. So I'll quickly jump to the partitioning area, right? And then I'll leave it to Jobin for a few more things. So, if you would be following the Postgres mailing list and looking at the discussions around, the improvements or whatever features are being developed, discussed, right? You could observe that there have been several discussions on some of the synthetic benchmarks done, and claims that there are 76 times improvements for select and 420 times for improvement for updates, especially for the planning time, right? So when you have a partition table with, let's say, thousands of partitions, right? There should be partition pruning in place, which was not so efficient in the past, right? So your query could just go ahead and hit the right partition that it could hit to. And even at the planning phase, it would not really consider the metadata of all the partitions, all the child partitions. It would simply go ahead and touch the right partition that it should. And so, for example, we'll go ahead and look at one of the benchmark that we have done. You could simply reproduce this, right? We're just creating a schema Scott and creating a table in it. And what we're doing is, in the year 2001, we considered a weekly partition, right? So Jobin has developed a simple Python script or a tool that's available as PGPartMaint, wherein it could go ahead and create future partitions, right? So we are creating 1,000 weekly partitions through that script, right? So we just created a partition table, and we created 1,000 partitions, and we inserted some random data, right? And after inserting, I just ran an explain analyze, select count of star from Scott orders, where order time between, Feb 1st and 3rd. So when I ran that, you see the difference. In PG11, the planning time is 29.740 milliseconds, whereas the planning time in PG12 is 0.157 milliseconds. Once, of course, the metadata is cached, it might further decrease in both. But when you have especially thousands of partitions, right? Postgres 12 is much more advanced. So it's pretty much improved in terms of performance. And it's not just select. Even you go ahead and do, for example, I've done an update, right? And if you explain, analyze, and look at the planning time, it's a lot of improvement, right? It's a lot of improvement in the planning time, especially when you even talk about updates, not just select. So I have got a planning time of 267 milliseconds in PG11, whereas with PG12, we have got 0.350 milliseconds planning time. So inserts to partition tables also have less locking. There are a lot of improvements towards inserts, deletes, updates, selects, right? And it's consistently, the performance will be consistent even with huge number of partitions. So talking about merge appends, there was an extra append that used to happen with PG11, especially when you have got a single subpath as well, which is now not needed with PG12. So that has been improved. So your planning time, right, even improved here in this section. And even merge append, right? So even in the past, like there used to be an additional stage, even when you have a single subpath, right? Wherein it needs to go ahead and merge all the subpaths when you have too many partitions in place. But it's just a single subpath. You don't need a merge append happening. So it further reduces the planning time and even the execution time, or the total time, which is planning time plus execution time. And attached partitions is no more blocking. It does not block your queries now, right? So earlier, attached partitions used to block, but now it doesn't block your queries. And at the same time, there's been some confusion around detached partitions also not blocking, but that's not right. So if you are running any queries on that table, detach would again not get into the blocking stage, and it would not basically finish. So you should stop all the activity on that table to go ahead and run a detach. And so for that reason, there is no separate syntax for concurrently on the attach, right? And creation of new partition to table, you could just go ahead and use like, right? And just say attach partition for values. And you have also got some of the functions that would help you understand what is the topmost parent and the ancestors, right? So there are PG partition root, partition ancestors, and there are some more functions that are available for you to go ahead and look at the partitioning metadata or the partitioning root. And talking about improvement with copy, so even bulk loading to partition tables is further a lot improved, right? So copy is bulk loading, which is of course a single transaction, right? So the algorithm behind that and the way it does interacts with the partition tables, the way it inserts data to partition tables is also improved. And even with PG dump, now you could even, when your PG dump is selected, is used to dump data with insert statements. While restoring, you could also go ahead and say the number of rows that it can insert per each statement, right? You could specify that with PG dump and PG restore now. And talking about inserts, again, it's less locking. Also, simple PG dump shows pretty good improvement, like we've seen there. At the same time, even in terms of the restore, you could always see great improvements when you are restoring data or dumps to partition tables. So earlier, with the older versions, we had this issue wherein we were converting some of the large tables to partition tables, right? When we do that, if there are foreign key references between the partition table and another table, right? The partition table could, of course, reference another table, but the foreign table, the other table, cannot actually reference a partition table. So now you could also reference a partition table. So that works with PG12. And partition boundaries, it can now be evaluated at the creation time. So earlier, we were only able to pass simple constants, right? For example, I go ahead and say create partition or add partition, attach partition for values from the values. Now I could rather use something like current date minus some number, right? So partition boundaries can now be defined as any expression. So we'll let Jobin talk about general performance improvements now.
Thank you, Avinash. And as you see, among 25 important points, 13 were partition related. So if you have a big table, Postgres 12, if you are planning to migrate to Postgres 12, the partitioning feature is the single biggest reason you should choose Postgres. So when we are preparing these slides, we were thinking that, okay, this may end up like it's all about partitioning talk. Yeah. So going to the general performance improvements. So there is changes in the internal algorithms also. So, the Postgres is a big community, and all improvements happening across the world in terms of the algorithms are incorporating into Postgres. So now the output, the algorithm is changed for the real and double data types. So it is fast and efficient, and it is consistent across platforms. So there is a implication for this. So if you are using your old drivers, there could be some minor change in the precision. So please go through the Postgres documentation about the real data type change, how it is outputted. So normally it won't be a big change. Yeah. And this is something really going to help you. You know the concept of toasting. Postgres stores the big data externally, just like say text or glob or blob, as a separate storage. And every time when you access those things for a query like PostGS or JSON query, the entire thing will be detoasted, it's uncompressed and searched inside that. But in Postgres 12, the operation is changed. Suppose if you are searching only the initial part of the column, only that part get detoasted. So most of your queries hitting on the toasted column is going to improve.
How many of you do not know what is toast? Okay.
Yeah.
All right. All right. Yeah, maybe you want to explain. Okay.
Yeah. So the concept is when you store text data type, we don't know the size. So it could be going to, you may be storing a big document. For example, if you are storing a JSON file, it could be multiple MBs. And the Postgres has a block size of 8 KB. And it won't fit into that. So what Postgres does is, it will store it externally. If anything more than 2 KB will be stored externally, and a reference will be stored in the Postgres block. And that external storage will be compressed because it's a big data. So that's called toast. Yeah, yeah. So there is very mild performance overhead because it's another block. Yes, of course it is there. So always prefer a data type which can store in place. For example, integer or things. We have the size precision, and there is some tuning parameters also associated with. We can adjust that size and all. Yeah.
Yeah. After what value, what size should it really go to toast, right? So you could have. I mean, the default is 2 kilobyte per record.
Yeah. Automatically does this toasting. Yeah. And without our knowledge, this performance improvement comes into place if you just upgrade to Postgres 12. Yeah, it's a different location. If we are querying on that column, say if you are querying on a JSON which is stored externally, that block need to be fetched. Yeah, it's user don't have to worry about that. Yeah, it's how it works internally. It's a separate block. So the entire block need not be decompressed. So if you are querying just like some expression, the first few characters you are searching for, sorry. See this like expression. So first few characters you are searching for. So for that, the entire block need not be decompressed. Only first few blocks need to be decompressed to answer this query. Yeah. So based on your query, Postgres will decompress only up to that point. So if you are searching for a JSON and you are searching for a field which is at the beginning of the field. So for example, JSON headers, only that header part will be decompressed. So you can test your case and see the performance improvement. Yeah. Yeah. So, yeah, 8 KB, 8 KB. Yeah. And this is another big improvement. So just upgrade to PostgreSQL and enjoy this benefit. So if you have CT queries. So earlier, how many of you use CT expressions? Yeah. So the CT will form a metallized, result set, and the subsequent query will be referring to that. The problem there is, once we materialized, it don't have an index, and index won't be used in the subsequent queries. But now in PostgreSQL, that CT will be decomposed and it will be added as a part of the query. And the entire optimization happens for the entire query. So this is a great improvement, and for those who are using, no, it's by default.
Earlier, we used to use CTEs, especially also in such cases when we have in the plan nodes, in the execution plan, if we saw that there are a lot of number of loops, right? And in order to reduce the scan, right, we would rather go ahead and create a CTE and let it join that, right? And now that's even improved further, as Jobin said.
Yeah. And still we have option to get the old behavior by adding that with metallized option. But we need to tell explicitly, okay, we want the old behavior. Otherwise, it will be optimizing it. And vacuum. Yeah, so the Postgres data size is growing, and we have a lot vacuum-related challenges. And community is addressing that with the extra clauses to the vacuum. So we can, at a table level, we can specify the vacuum, to the vacuum that we need not clean the index now, when there is a critical situation as part of the table vacuum. So this is very useful when we are handling some vacuum freeze operation, emergency freeze operation. We can just say that, oh, don't clean the index, just clean the table and let's proceed. So most of the work will be faster. And the next option is skip locked. The partitions which are undergoing some transactions will be skipped here. So we have all these new options for fine tuning the vacuum. And this is a new feature. This JSON path, just like XPath expression and all, JSON path expressions are introduced in SQL 2016 specification. And Postgres is one of the front runner in adopting those standards. And now we have the standards. So the big challenge faced by developers is that there is no standard for JSON access. So MongoDB has their own way of accessing, different database has their own things. And finally, we have a standard, SQL 2016. And Postgres has that. And I'll be giving some demo related to this later. And this is another big improvement if you are doing a data load using copy command. So now we have additional where condition. This long pending demand from the community. So you can filter the copy operation. And checksum. A few minutes back, Robert Haas was mentioning about PG checksum, the importance of checksum in the database. Yeah, so up to Postgres 11, enabling checksum was difficult. We had to reinitialize the cluster, dump, and restore the data. But now, in PostgreSQL, enabling is very simple. We have this tool, PG checksum, is included into Postgres distributions. Existing thing.
Yeah.
So if you are worried about data corruption, definitely do this. Yeah.
Just with a restart.
Yeah. Just need to restart. And this is something new. Even yesterday I was working on a customer case related to this. So now Postgres has these generated columns. You can see a table here, right? And we have a column since. So it's a so we can have a column. For example, I want to find out the age out of date of birth. So earlier those things were done by triggers or something like that. Now when an insert happens into table, we can have a function which will execute at the same time, and it will extract the data and store it or do some activity. It's a very useful thing. So people who store updated timestamp or something using triggers, now it is easy with the generated columns. So let me give you a small demo of that. Yeah. So in this table, this is a table to store the candidate information of employment, and the jobs column. There I am going to get his resume data in JSON format. And then I want to calculate experience out of that and store it in a different field so that I can do some sorting operation or something. Okay? So the table is created. And this is the JSON data I am inserting into that table. And I'm properly showing it in pretty print. So his first job was started in 2001. And see, the experience is calculated out of that. So not just JSON, you can use it for calling any function, any custom function, and which will get executed, and the result you can store it in table. So a lot of analytical work will be simplified. Sorry? Not select. At the time of insert or update. At the time of insert, yeah. Correct. It will update. Yeah, of course, there is it's a function call. So obviously there will be. Sorry?
Yeah.
Plan.
Can we do that at the end? Okay. We just have 10 minutes.
Yeah, we are running out of time.
We are running out of time. We have a lot of things to show. We can
have
show
a lot
that
of
at the
features
end.
to show. Yeah. Okay. And another thing, actually, I want to show this also, but we don't have time. So those who are migrating from other databases like MySQL or other systems, they have non-deterministic collations. So for example, you want to say, for example, here you see in the table I am storing with a capital letter first, so the case insensitive comparison with the capital letters, but I can query with the small letters. The result will be shown. So we can create custom collations. So Postgres introduced these ICU libraries a couple of previous versions back, and now we can have all those ICU related parameters specified in the collation so that we can leverage everything in the ICU. So you'll get the same behavior as MySQL or other database in Postgres. So applications which are portable, yeah. So handing over to Avinash.
Yeah. All right, so talking about the standby database improvements or changes, right? So you don't have recovery.conf file anymore when you go ahead and set up your replication, right? When you go ahead and configure streaming replication, until Postgres 11, we used to have a recovery.conf file where you will set such parameters like primary con info, standby mode, and all the other recovery related settings. Now you don't have to do that, or you don't have to create that file anymore, right? So you have several Postgres recovery related parameters now as part of PG settings, which can be added to the PostgreSQL.conf or the auto.conf file. So if you just go ahead and say select name, setting, where name like recovery, you see, primary con info and other related parameters, right? So even primary con info, primary slot name, like these were not part of the PostgreSQL.conf file. These were part of recovery.conf file. So to see all the recovery settings, like you could just say, select name and setting from PG settings where name like recovery percentile, and you see all the recovery related settings now as part of PostgreSQL.conf. So when you create replication slots, right? When you go ahead and create replication slots, especially when you're using logical replication, or also when you're even using it for the purpose of storing the walls until they are applied, right? So that's when you go ahead and create slots, right? Yeah. That does not change. None of that behavior changes. It's just the parameters that you configure in the recovery.conf file, right? Those parameters that are changed. What is the next? Oh, yeah. Okay, so when you go ahead and use PG based backup, and let's say you use the flag hyphen uppercase R, it used to create the recovery.conf file in the past. Now it creates a standby.signal file instead and adds the primary con info automatically to the auto.conf file. So if you go ahead and create your standby using PG based backup simply by doing a plain dump and and then go ahead and specify hyphen uppercase R, it creates a standby.signal file, and this is the file that actually tells whether it's a standby, right? And then if you look at PGs in recovery, like that used to be the function that we used to run on the standby. If it's set to true, it means it's a standby. Now you could also run select PG underscore promote in order to promote a standby. Earlier we used to say PGCTL-D data directory promote on the standby, which is an OS using the PGCTL. But now you could just run it as a function. A user could even just run it as a function, right? And then PGs in recovery, of course, false, because when you did a promote, it just gets promoted.
So we need not get into the server. We can remotely promote a database server.
Yeah,
through Postgres connection.
Right. So you also have this trigger file that you could also create remotely, right? If you just touch this file, it even gets promoted. So now that parameter is promote underscore trigger underscore file that can be set as part of PostgreSQL.conf file. So there are two signal files, recovery.signal and standby.signal. If standby.signal is present, it means the database is in the standby mode. And if recovery.signal is present, it will start the targeted recovery. And of course, takes up to the parameter like recovery target timeline, until what time you want to recover the latest, or until a certain point in time you want to do a point in time recovery. Those can be configured, but it's as part of the PostgreSQL.conf or the auto.conf file. And why we are telling this is because your HA solutions, if you're using any HA tools or custom HA tools, you may have to modify them so that they fit the PostgreSQL 12. And even your backup tools, if you're looking for recovery.conf or trying to back up in different ways, just go ahead and check if you need to perform any modifications. And yeah. So talking about PSQL improvements, you could use now the following formats, even HTML formats. You could use PSQL and just specify the format type that you want to display, right? And you could also get the output in the HTML format. So all those formats are available, but even LaTeX. And much more advanced help options available with PSQL now with PostgreSQL 12, wherein even tab completion of create table, create trigger, all those would also work.
Yes,
right?
So a quick demo on that. So, for example, if you the help is improved. So if you say normally if you say -h, more help is available on PSQL prompts. So if you are writing any query on the fly, you will get more help. And you can see there is a link also to the
at the bottom. You can just click that.
And if you are using any kind of Linux terminal or Unix terminal, this in the terminal itself, it will become a link. So as you can see, it's a link. So if you do a control click, automatically that link opens. So while writing query itself, you have more help available. So it's not just single command. the command combinations also say create table, then you don't know the syntax. Okay, from there onwards, you can get the details. Yeah, yeah,
Yeah, slides. Yeah. All right. So now even if you need to look at the list of partition tables available, you could use this help option /d uppercase P. In order, yeah, okay. So also at the same time, even if you would like to look at all the help options available, just say /?. So you see all the shortcuts, right? And earlier /d would not use to display a partition table, like with type as partition table, but now it does that, right? Of course, you set your search path to the right schema, it displays the list of tables in that schema. And talking about indexing improvements, as I was talking about it earlier in the beginning, now if you go ahead and dump your older database versions, database dump to PostgreSQL, you actually see that the database size could be decreasing, right? And that is and at the same time, the B-tree indexes, especially the multi-column indexes or the non-unique indexes with duplicates, you see it really not storing the way it used to earlier. So now the space used by those indexes is also reduced because it just, for those duplicates, it just uses the same point, multiple pointers to the same duplicate record, and that way you don't have to store it twice, and even vacuum cleans up the indexes with duplicate values. So everything is optimized in the best way in terms of indexing. So when you create an index, you see an index taking very less space with PostgreSQL. And talking about Reindex, now you could go ahead and use, earlier you used to use something like create index concurrently and then rename the index. But now you could even perform reindex concurrently or reindex all the tables of all the indexes of a table concurrently. So the reindex concurrently option is added with PostgreSQL.
Yeah, DBS like me used to write custom scripts, tools to achieve this. Now those projects are not required. We have the feature built in.
Yeah, you used to create a new index concurrently and drop the old index, rename this index, which used to be a bigger approach, right? So now even just like B-tree, even just index supports include option, right? Include only plans. And so you want to go ahead with from here? Yeah. Okay.
Yeah, so as you shown, the val generation is optimized now. The index creation takes very less val generation because index is created and it is rescanned and the vals are added later. So there is optimization. And the val replay related to index generation is further optimized. This is especially when you have a standby and there is heavy traffic. Yeah, coming to optimizer improvements, Postgres collects default statistics, and we have options to collect lot more extra information so that the optimizer knows much better things. So the first is a case of column dependencies. So, for example, Bangalore, if I'm storing in a table, that has a dependency of to the state. Okay, in the same table, if I'm storing a state ID also, the city ID and state ID has a relation. Similarly, if there is a pin code, all those things have functional dependencies between columns. So this way stats collection will allow more information.
Done with time.
Yeah.
Just,
and it is further improved by multivariate column because it not only just column-wise dependency, we have row-wise dependency also captured now. Yeah.
We're done with next talk is starting. We'll just quickly go through the slides.
Yeah. And the prepared statements, now we have option to explicitly specify whether custom plan or a generic plan. So tomorrow I'll be talking about this in my session. Yeah. And JIT is enabled by default. And J8 is not always great not for all the workloads, so be very cautious about that. And there are monitoring improvements.
So earlier you used to have this logmin duration statement, but now we also have this sample rate where you can go ahead and set a sample rate of 10%, so 10% of queries can be captured. So that way, like it's not that the faster queries are not getting captured, but now they can be captured with a sample rate, right? So we can talk about that offline because that's a big topic.
Yeah, so more monitoring views are created. Not only just vacuum, the cluster and index creation, now we can see the progress.
You could see the progress of an index and create index and a vacuum full.
And security related improvements. Now we have the full client certification verification, which will do the 3 levels of checks. And now we have option for multi-factor authentication. We can not just one method, we can have multiple methods. And there is a security improvement related to the specification of SSL version we need to use. Yeah, min version and max version we can specify. So sorry, I am just rushing through the main points. And this GSS API authentication is included in Postgres, which will allow us to have single sign-on. Yeah, so a few more additional references.
Yes.
Yeah.
Yeah, so that's all we have for today. Thank you, and we'll be taking any of the questions offline during the lunch.